Morning, everybody. Thank you for joining us today for this presentation on the Chemio disinfection in the food industry. I appreciate you all taking some time out of your day to join us here. I'd just like to firstly say, if you have any questions, please put those into the text box as we're moving through, and we can look to answer those at the end of the presentation. And we'll address any questions at the end. Now, let's move forward. So, presenting today with myself, James Matley. I'm the Business Development Manager for APAC, and Sunera Naidu, who is our Technical Support Coordinator, also for APAC. So we'll run through various aspects of the Chemio in the food and beverage industry, and then Sunera will cover off anything technical at the back end regarding the science behind the instrument. So we have our APAC team. Genevieve covers the Australia region. Lustar is our warehouse supervisor and responsible for all of our dispatch. Shweta Beniwal, bookkeeper, and Sonata, who is the head. Okay, so the agenda today, we'll cover the features and benefits of the Chemio, how it's used in food and beverage, the particular applications and parameters required, as well as the value proposition of the Chemio, and then lastly, the science behind how the Chemio works. So pay and test purpose. So we exist to safeguard water for everyone every day, and all of our sort of development goes into that focus. We're simple to do business with, innovation which benefits and delights, as well as operations that match our growth. So we have multiple products, multiple technologies that we use to monitor water quality. These range from basic kits such as visual, where you're just dipping potentially a sensor into the water, or mixing a reagent and comparing the colour against a colour chart, up to our electrochemical sensors, as we're going to talk about today with the Chemio, which allows for lower range monitoring, better accuracies across greater ranges. So, Chemio in the food and beverage sector. So what is the Chemio disinfection? It uses electrochemical sensor technology to measure various parameters that include chlorine free in total, chlorine dioxide, peracetic acid, chlorite, and bromine. Benefits of this instrument include its portability, ease of use, and its accuracy. And it's also a robust instrument. So it's IP67, which means it can be around water and not run the risk of ingress. Accurate testing in 60 seconds. So you get quick testing for PA and chlorine, allowing for operators and engineers to move quickly through lines to monitor. Suitable even in turbid or murky water. So you have various applications where leaching from, for example, beetroot will cause discoloration of water. Salad will have dirt that, again, finds its way into the sample. The Chemio allows for monitoring without having to filter these samples. Please, clear, easy to follow on-screen instructions. So here you have an instrument that provides you with step-by-step protocols for every parameter that you're measuring, as well as streamlined data management. So all the information is stored on the instrument, as well as integrated into the cloud on our Pale and Test Connect system for data management. So food processing, there's various different applications that we monitor here, but key to each of these applications is optimal water quality, and this is critical. Within optimal water quality, you have hygiene and freshness, regulatory standards that need to be maintained, the prevention of contamination from bacteria, microbes, etc. And you want to ensure the taste of the product is not affected as well, because at the back end, that is obviously key to the customer satisfaction of the product. So the Chemio gives you quick, reliable results here to maintain your water quality in all these applications. So the Chemio is generally used as a secondary instrument in food and beverage applications, where you'll have a primary instrument, which is online / inline, which constantly measures the process, and the Chemio is used for spot testing and calibration of this equipment. So when you do a test, you put the sensor into the instrument. You then collect your sample and enter the sample chamber. You close the head. into the sample, and then, as mentioned, within a minute you have the result. From these results, you can adjust your process to either increase or decrease the level of disinfections used. So you have like the optimal range that you want to operate your process. And then it's cyclical. So you monitor, adjust, monitor, adjust. So this constant process allows for optimization of your process. So there's key people you want to talk to or who are involved in this process, in this application. These include health and safety and food safety managers. There'll be sort of umbrella to cover all of the operations, quality control technicians, production supervisors, and also operators. So various people will either see the data, use the instrument, or just oversee the operation. So these are all people that you want to understand the requirements of the process. So key to the KO and the food and beverage industry is our value proposition. So number one is mitigating operational downtime. So through accurate, you can ensure that the process is maintained at the correct level. So let's look at improved accuracy. So as I've already mentioned, the simple on-screen instructions allow for minimal training from engineer to engineer. It means that each sample is processed in a very similar way or exact same way because the analyzer tells you exactly what to do. What you might find in other technologies such as photometry is that from engineer to engineer, they might use a different amount of powder because if it's done by eye, you could have different levels of reagent mixed into the water sample. Reagents may not dissolve enough, therefore not completing the chemistry behind the sample taking, and therefore you won't have an accurate result. Not waiting enough time for the chemistry to occur. So these are all areas where the KMO does have an advantage over photometry. You have regulatory and compliance control. So through consistent results, even in turbid samples or coloured samples, means that you can be positive that the results that provided by the KMO are accurate. Compared to other instruments other instruments such as photometry, where you'd have to filter the sample if it was dirty or coloured to remove that discoloration will affect the reading due to the light. So, also regulatory and compliance is safety. So there's no glassware required with the KMO. So there's no issue with breakages or any parts of the instrument getting into the process. And traceability of the results. So from the point that you receive the sensors, they are traceable to the manufacturing side. That's when all results are recorded on the instrument and can't be deleted. And then once the results are scanned on the phone or through another method, they're stored on the cloud and can be viewed by your compliance manager, safety manager at any time. So the traceability of the results is very important to ensure you're maintaining the regulatory compliance within your particular country or the customer requirements. Save time. So compared to titration or filtration of the sample, the KMO will give you a result within a minute. So no reagent handling or sample preparation. And lastly, optimizing your chemical usage. So real-time feedback on your PAA levels or chemical, for example, or chlorine, for example, will reduce the amount of chemicals you require to use, which will save you money, which is always very important. So we'll briefly cover some of the processes that we are part of. So firstly, post-harvest production. So this can be salad, fruits, etc. Critical control points are where you need to understand are important for each client because these will vary from customer to customer. So some will monitor at the wash water stage or the bathing stage where you clean your product. Others may monitor at a stage where they're freezing the fruit, for example, to ensure that the PAA levels are low enough at that point as the fruit goes out. Other areas include X-rays or metal detectors. So these vary from site to site, and also due to regulation, they can vary. Typical parameters include peracetic acid, chlorine, and free and total chlorine, as well as chlorine dioxide. So poultry, again, that varies from country to country. So in the USA, for example, they clean the birds with chlorine. That's a requirement that they have there, whereas in the EU, we don't clean the birds with chlorine. Asia, we find there's a bit of a mixture of both, and in Australia, they'll use chlorine dioxide. So in some applications. So this varies from country to country. So it's good to understand what their process is from the outset. And again, these areas that are these critical control points will change from customer to customer. So asking questions upfront and understanding exactly the process and the monitoring requirements is important, because you might use high temperature, you need to have the correct sensor for the correct application. And typically we see chlorine dioxide, chlorine and peracetic acid in this application. Bottling and calf line is a bit different to the other three we'll discuss, because they use multiple chemicals during the process. So in the water packaging sterilization stage, they'll use PAA at a very high concentration, upwards of sort of 20 to 30,000 ppm. Then they'll use chlorine for the water source treatment, equipment sanitization. So both of these can be monitored using the Chemio. You'll also have ozone, which is put into the bottle because of its absence of chemical residue at the back end when the water is now in the bottle, and then hydrogen peroxide for aseptic filling system. So there's multiple chemistries going on with this application, and the Chemio is great for this because there's no effect from hydrogen peroxide. And we use our Lumiso Expert for parameters that the Chemio doesn't monitor in this particular process. So we lastly move into fresh red meat. So this is quite similar to poultry. And again, it's just understanding critical control points within this process. So you need to understand where these are. These are defined by the customer or regulation, and they do vary from site to site, as we've learned during our experience with Chemio into this market. And key parameters here again, chlorine, peracetic acid, and chlorine dioxide. Okay, so that was a quick run through the processes, the people you do, as well as within this process. I'll move you over to science behind the Chemio.
Buddy, Hi everyone, sorry, little bit of a technical glitch. Thank you once again. I'm Sunera and the Technical Support Coordinator for your region. Please allow me to take you through the science of Chemio. So there's a bit of a lag on my side, so please bear with me whilst the slide changes and I can talk to you. So I know James touched in earlier on about what is your Chemio and how to perform a test, but how does it actually work? So Chemio is an instrument that uses a technique called chronoamperometry, which essentially means that it measures a current over a period of time. It does this by pairing with a specific sensor. So what essentially happens is a water sample comes into contact with a sensor, and that generates a current, which essentially gives you your reading on Chemio. The current is proportional to your concentration of the analyte that you're testing for, and that's equivalent to your disinfection or water quality. So what is a sensor? A sensor is a disposable strip that's pre-dosed with a particular reagent. Now, how do sensors work? A sensor is again, sorry, I'm just waiting for the slide to change over. There's a bit of a lag on my side. So essentially, let's have a look at what a sensor is. A sensor, as you can see a little image of one, comprises of a working electrode, a reference, a counter electrode. It also has conducting tracks and an instrument interface. Now, the sensor or shall I say, the working electrodes are pre-dosed with specific reagents to react with a particular analyte that you're testing for. In this example below, we have peracetic acid, which is the analyte that's been tested, and the sensor is then dosed with potassium iodide, and that gives you a chemical reaction. So when peracetic acid comes into contact with your potassium iodide, it produces a chemical reaction on the surface of the sensor. What happens further on? And let's have a look at a video to explain this further. So as you can see, the sensor is inserted into your instrument, which is your chemio instrument. The sensor comes into contact with your sample. And let's go in depth and see what happens on the surface of the sensor. So we have the sensor pre-dosed with potassium iodide. This potassium iodide reacts with your peracetic acid. The peracetic acid is then oxidized. So you have the iodide ion, which is oxidized. Then the reduction of this oxidized iodide ion produces a chemical reaction or an electrochemical reaction, which produces a current, and that current is measured over a period of time. The current that's measured is proportional to the concentration of the peracetic acid that you're testing for. So let's have a look at the video again to see what it actually does. It's a similar process that happens with all types of disinfection that the chemio is able to measure. Chlorine dioxide, peracetic acid. So it's a similar type of reaction. The reaction occurs on the surface of the sensor. It's an oxidation and then a reduction, and that oxidation reduction or the redox reaction generates that electrochemical reaction, and that produces a current, and the current is measured on the chemio, and that current is converted into a concentration. So that's basically the science behind chemio for the chemio disinfection, and that's how it works. Now let's have a look at the different types of sensors that could work in one's application. So we have several types of sensors. Under the large umbrella of chlorine, we have chlorine at a low range. Chlorine can be measured at high range. Also free chlorine measured at high range. So there's various sensors under each umbrella. And each sensor works within a specific range. It also works within a specific temperature range, which means that you have to give a bit more attention to how you're selecting a sensor to suit your application. And you can reach out to us at any point if your customers or yourself is having a bit of difficulty in deciding which sensor would work best for your application. So now let me take you through a bit of Connect. So Connect is essentially our platform that enables an end user to upload their data, monitor their instruments, and this just gives reassurance, reliability, it's easy access of data. So if you're sitting out on site, you have a technician that's actually performing a test, and you have your quality assurance sitting remotely or away from your test site. The individual or technician can then scan the results that they tested during their analysis, and it gets uploaded to a cloud platform where a quality assurer or manager sitting off-site can access that data quite easily by logging into your Connect profile and monitoring data in that way. Connect also provides data reports, so you can easily access or track your data, monitor. It also flags your instruments for calibration, and there's a whole world and accessibility that you can discuss further with us regarding Connect. And to sum up, let's have a look at to sum up everything that we spoke about. If you were a client, and I'm going to take you through a client example of what did they buy and why did they buy it and how did they come to that decision. So in this example, we have a poultry processor, and poultry processors generally generate over 4 million kilograms of fresh air-chilled chicken annually. So that's a lot of generation for product. This particular producer used peracetic acid to disinfect their work process, their product. What did they buy? So this poultry processor purchased 2 chemio disinfections. It was more likely that they had 2 different sites that they were monitoring or 2 different points in their process that they wanted to monitor. They also purchased peracetic acid sensors that were used to test for peracetic acid. Now, why did this particular processor purchase the chemio? So they preferred chemio because chemio was preferred by their operators due to the ease of use. Do you remember we briefly took you through the sample process at the start of the presentation? It's just sample into a sample vessel, drop down, a reaction occurs, and a result is generated. So it was very easy to use. It was quick because your result is provided in under 60 seconds, and it's also reliable. So unlike titration kits as well, the chemio works 5 times faster. So you can work 5 times faster to mitigate any issues that come about when an anomaly result is achieved. So your reaction time is quicker. Also with a reagent or disinfection like peracetic acid, the sensors work without interference from your hydrogen peroxide. So the sensor or the technique as a whole eliminated bias. It also ensured that the operators worked consistently because of how easy the process is in using chemio. You can ensure consistency in how the operators perform the test. The chemio is also portable, so it means you can easily carry it onto your site. It's digital, it's user-friendly, and the instrument, due to its IP67 rating, is very ideal for all these industrial processes and environments. So chemio also works with colored samples, and essentially that holistically is why this particular poultry processor went with chemio. Now, to sum up on my side, thank you all for joining our presentation, our webinar for today. If you have any questions, please feel free to put that into the chat. James and I are here to help you with any type of questions that you have, any clarifications that you need to go over. So now's your time. We can't hear you, so if you would please put those questions into the chat.
Cool. Okay, so let's have a look. Oh yeah, so yeah, thanks everybody for joining us today. I really appreciate the time you've taken out of your day to spend this with us. Yeah, we can hang around here for a few minutes and wait for any questions that pop up about the presentation, or if you just have any queries regarding particular applications that you've been involved with, or any new applications you're working with. Cool. Okay, well, we'll wait another few seconds, but yeah, so just again, thanks for coming today. Please follow up by emailing us or calling us if you have any queries regarding processes in your territories. But yeah, look out for a recording of this if you want to watch it again, and we will be in touch with any future webinars. Take care. Have a great day, everyone. Thank you. Bye.